So graphs of rational functions let's look at the simplest rational function. F of x is equal to 1 over x. This is the simplest rational function. And let's try to graph this thing, and we'll just use an xy chart. So I'm going to make an xy chart. And suppose I pick x is 1. Then what is f of x, or f of 1? That's going to be my y, right? So I plug in x is 1 here, I get 1 over 1, so this is just going to be 1. What about when x is 2? What is f of x, or f of 2? F of 2 is equal to 1 over 2. Right? I'm just plugging in, I'm choosing a value for x, and I'm plugging it into this function. What about 3? 1 over 3. What about a negative 1? Negative 1. How about a negative 2? Not 2. Yeah, a negative 1 over 2. Is that what you said? Yeah. Oh, okay. Oh, okay. So we can keep choosing some points here, but let's choose. What if I chose x to be a fraction like 1/2? Then f of 1/2 is equal to 1 over a 1/2. What is 1 divided by a half? Not a half. How do we divide fractions? You take the reciprocal and multiply, right? So this is the same thing as 1 divided by 1/2. Well, we take the reciprocal of this, so we have 1 times 2, which is 2. What is, if I chose a negative 1/3? What is f of a negative 1/3? I think I heard someone say it. Negative 3. What about x is 0? Can't do that. Why? Yeah, because if I plug in a 0 for this x here, I'm going to have 1 divided by 0. We can't do that. So 0 is not going to be in the domain. Let's look and see what this graph looks like. So let's see. Give me some hash marks here. 2, 3, 4. So 1, 1. There's 1 point. 2 and then 1/2. So x is 2. My y now is going to be 1/2. So somewhere about right there. 3 and then 1/3. So it's getting closer and closer to the axis here. What about a negative 1, negative 1? Negative 2, then a negative 1/2. So that's going to be about right there. Now when I chose x to be a half, so that would be right here, I got y to be 2. So that's going to be way up there. If I chose x to be a third, I didn't write it down, but we can see that if x is a third, then y is going to be 3. Something like that. What about negative 1/3? So negative 1/3, y is a negative 3. So that's 1, 2, 3 down here. Okay, so if I picked a whole bunch more points, we could see the graph's going to look something like this. And that's basically what a rational function graph would look like. Notice that if there's no part of the graph above x equals 0, right? That's because x is 0 is not in my domain. I can't define this function for x is 0. These lines, anyone know what this line is called here? As a graph approaches a line, but it doesn't ever touch. This line is a vertical asymptote. Vertical asymptote. We also have a horizontal asymptote. This line, the x-axis, is a horizontal asymptote. Okay. With rational functions, you will always have a vertical asymptote. Where do you think you might have a vertical asymptote? So notice here I have a vertical asymptote where? At x is 0, right? What do we know about that x is 0? It's going to be the origin, but what do we know about for this function? Right, x is 0 is not in the domain, and that is precisely where we have a vertical asymptote. Okay, so I think we'll do some more in later sections, a little bit more, but this is just an introduction to these graphs. Any questions? So the biggest thing that we want to do with rational expressions is we want to simplify rational expressions.